if you get to be 65 or 70 and later, and the people that you want to have love you actually do love you, you're a success. I've never seen anybody that reaches that age. I mean, I'm not talking about somebody that's in extreme poverty or pain or something, but I've never seen anybody that, if they have a lot of people that love them, that is other than happy. And I've seen some very, very wealthy people that they give testimonial dinners to and name schools after and everything. And nobody loves them, you know.
Hi and welcome back. In this video, we're going to look at how to run Python from our console. Sometimes we won't have access to PyCharm or, an IDE when we're running our Python programs because we'll be in, for example, a server, or we want to share a program with someone who doesn't have that IDE, and so forth. So it can be handy to be able to run our Python programs outside of any specific environment. So the console is a text interface to your computer. You probably have come across it before. You can basically run anything by using text. You can open files, copy them, you can run programs, basically anything that doesn't have a graphical interface. And many things in software are done through the console just because, sometimes it's not worth developing a nice graphical interface. If you're making a tool, for example, to help you with formatting your code nicely, sometimes you don't need a graphical interface for that. If you're accessing a database, you may want to only run the SQL commands and not necessarily have a graphical interface that goes with it. If you're writing code, sometimes you may not want a graphical interface to write your code with. Maybe a text editor is enough. There's many situations where there's just not a reason to have a nice graphical interface for something, so whoever developed that just made it into a text program. And those text programs normally run in a console. So in order to open a console in your computer, you can open cmd.exe on Windows. If you search for it, just type cmd.exe on the search bar or wherever else, depends on the Windows version you're using. I'm sure it will come up. It's a very popular thing in Windows. If you're using Mac, you want to open terminal.app. This is the app that Mac comes with in order to launch a console. And on Linux, you can open the terminal app. Any of these will give you essentially something that looks more or less like this. It'll be a black box with some text in it, and you can type some more text. Here's an example of typing Python in that console. When I type Python, what appears is some more text, and then 3 crocodile clips at the bottom, and there I can type some Python code. And this program here will immediately run the Python code I type, and essentially let me type Python code in real time and see the output of the code immediately. By the way, Python 2.7 is the version you can see here, and that's the default on Mac OS X, which is what I'm using. If you're using a different operating system, you may see a different number here. For example, in this example here, I'm running the program Python 3.7, which is all one word, and that's a single program. And then you can see that runs Python 3.7.0 B1. This is the beta. When I was recording this course, Python 3.7 hadn't come out just yet, but it was already available just for early adopters. So Python and Python 3.7, completely different programs. Even though they are essentially the same Python, a different version, they're completely different things to our computer. You could type anything in here, and what your computer is going to do is it's going to try to run whatever you type. And it just so happens that Python and Python 3.7 are two things that our computer can type. By the way, on Windows, this will only work if you checked Add Python to Path during the initial installation. But if you didn't, you can reinstall it and make sure to check it. And that's this little box over there. It may look slightly different in newer Python versions. Just make sure to check it, this box, when you see it if you're on Windows. Otherwise, it won't be added to the path and it won't work on your terminal or on your console. So what is the path? I've been talking about the path as something. And this is a global variable that your operating system uses to specify where to find programs that you may want to run. So when we type Python, that's a program. And if the program is inside a folder, and that folder is inside the path, then this will work. Your computer will be able to find the Python program, and it will be able to launch it. If it is not in a folder which is in the path, it won't work. It will just tell you, we couldn't find this program. Here's an example of me running a program that was not found. I typed ngrok, which is another program, but I don't have it in my path, so it just said, command not found. My computer doesn't know what that is. You could have installed this program. You could have, downloaded this program, but if it's not inside a folder which is in your path, your computer won't be able to run it through the terminal. So that's important, okay? So you can see what's in your path by typing this on Mac OS X or on Linux. Just type echo $path, and it will tell you all the folders that are part of your path. Any program that you have inside any of these folders will be executable by you typing the program's name. As you can see, you've got something like /library/frameworks/python.framework/versions/3.7/bin. And then you've got a colon, and then the next folder begins. So you've got a few folders, or I've got a few folders in here, and as you can see, one of them is the binaries folder of Python 3.7, followed by, some Node version 8.5, followed by some Ruby thing. There's a few things here, a few folders, and whenever I type Python, what my computer is doing is it's going into this bin folder and it's checking if Python is there. If it isn't, then it moves over to the next folder, and then to the next one and so forth. And if it can't find it in any of them, it'll say command not found. Okay, so echo $path on Mac OS X or on Linux will tell you what's on your path. And on Windows, there's a few steps. As usual with Windows, you've got a few things to do, but I've attached a blog post to the resources section of this lecture. You can see it if you click on the curriculum down here on the top left, and there's a blog post attached there with some instructions for the various versions of Windows, Windows 10, 8, 7, and so forth. And so you can have a wee look at that. So environment variables, well, the path is an example of an environment variable, and these are just global variables available to all programs that run in the environment. And normally the environment is your computer. So if you have more than the path as an environment variable, your programs will have access to the path and whatever other variables you decide to have. And you can have multiple ones if you want. And here's how you can look at the environment variables you've already got. So if you type export on Mac OS X or on Linux, you'll see all the environment variables you've got currently available. You can create more, and we're not really going to get into how you can create more in this course, but you can create more, and then any program you launch within that environment will have access to those variables. The resource linked in this lecture explains how you can add more environment variables on Windows. Modifying your path is something you can do, and again, the resource linked in the lecture explains how to do that, but it can be dangerous. Because your computer is actually relying on the path to find many of the programs it uses all the time, if you change it and you make your computer unable to find a lot of the programs it needs, you may have some trouble. So just don't change the path unless you know exactly what you're doing. Just reinstall Python if you have to on Windows and make sure to check add to path in order to make it work. That's it for this lecture though. I just wanted to give you a quick overview on what the path is and how you can open up Python from your terminal. In the next video, we're going to go a bit more hands-on and actually write some code in the terminal. I'll see you on the next video.
You know, I don't think people will believe it, but I think it's self-taught. I don't think confidence is something that you are born with. I don't think confidence is, it's a skill set. And I had no confidence growing up. As a child, I had very low self-esteem. I was gawky as a teenager. I lived in America. I was made to feel conscious about the fact that I was Indian. That was weird at that time. And not by everyone, but just by like a few bullies in school that hated me, and high school's hard for everyone. But so I was in a very weird sort of teenage place, and when Miss India happened, I'm inherently competitive. I think the fact that I was competitive pushed me to teach myself to be confident.
Hi there and welcome back. In this video we're going to be running a couple of things in the terminal just to show you how it goes. What we looked at in the last video is that if you have Python in your path, you should be able to launch the terminal app on Mac, terminal on Linux, or cmd.exe on Windows in order to open up Python. So let's do just that. I'm going to type Python and then press enter, and as you can see, I get Python 2.7 because that's the default on Mac. Here we've got our Python interactive interpreter. Python comes with this program, and essentially when you run it, it just opens up an interpreter in Python that you can type Python commands into, and it will execute them immediately. So you can type something like print hello world, and it'll print it out to you. You can define functions, and then as soon as you type the colon, this realizes that you're typing a more complex command, and it gives you a new line where you can type. Make sure to press tab at this point in order to add the spacing that the function needs. You know that functions need to be indented more at the beginning inside the block, and then you can type enter twice in order to exit the function. Then you can run the function and it will return the result. This is pretty powerful, having an interactive interpreter like this. As you are typing Python code to include in your programs, very frequently I'll have something like this open on the side where I will copy and paste from my code just to see that everything's working as intended. Instead of writing your code and then running it and waiting for it to work, you can make sure it works by putting it here first and checking it first. This is something I do very frequently. Once you want to exit from this interactive interpreter, instead of closing the window, which is something you can do, of course, you can press Control D. So that's going to be Control and D. I'm going to press those two keys simultaneously, and then notice how Control and D gets printed out here, and this exits fully. Now, Python runs the default Python version of Mac OS X, which is Python 2.7. If you don't have Mac OS X, running Python probably runs the Python version you've installed at the start of the course, maybe Python 3.6 or 3.7. If you are on Mac or on Linux and you've got multiple versions of Python installed, you can always type Python 3.7, for example. I believe this will work on Windows as well, but Windows can be a bit picky with the things that do work and don't work on a terminal. As you can see, typing Python 3.7 brings me to Python 3.7.0 Beta 1. This is the early adopter version of Python that I'm running. And here you've got exactly the same thing as before, another interactive interpreter, but now it's running Python 3.7. What does that mean? Well, it means you've got access to things like f-strings and things like that. Not that you'd want to do this, but just to show you that in Python 3.7 now you have access to all the new Python features, as you would expect. So if you're typing Python 3.7 code in your editor, in your program, you'll want to launch a Python 3.7 interactive interpreter in order to test out your code. If you want to write your programs in Python 3, but you launch a Python 2.7 interpreter, you may find that things don't quite work as you would expect. So that's something to keep in mind. Again, I'm going to exit this interpreter by pressing Ctrl D. And now I'm going to show you a command that is only available in Mac OS X and Linux, but it can be used to look at what program you're running when you type Python 3.7. See, when you type Python 3.7 in your terminal, what's actually happening is that you're looking for the Python 3.7 program across all your folders in your path. Okay? So I'm going to print out the path, and you can see that the first folder here is this library frameworks python.framework versions 3.7 bin. Then a colon separates this folder from the next. When I type Python 3.7, And when I type which before it, it tells me what program I'm running when I type Python 3.7, and that is this program. This program is inside library, the library folder, frameworks folder, python.framework, versions 3.7 bin, which as you can see matches exactly the first folder in the path. And then inside bin you've got Python 3.7. So this tells us that the Python 3.7 program exists within our path, and it also tells us where exactly in our computer it is. If you type which of something that isn't in your path, like ASDF, it just won't say anything. Okay, so this is a good way to check whether you've got things in your path or not. Similarly, if you type ASDF, it'll tell you command not found. So, if it's not in your path, you'll get a command not found or a similar error in Windows and in Linux. Now that we know a little bit about how to actually do this in the terminal, we can go and look at how we can create and manage our projects using the terminal with a couple of tools that we're going to be introducing in this section. And I'll see you on the next video.
What was your biggest failure and how did it change you?
Wow, I have to really think hard about that. Failure. Never heard of it.
There's your answer.
Well, there's a ton of failures along the way, that's for sure. Like I said, as I said, for SpaceX, the first 3 launches failed, and we're just barely able to scrape together enough parts and money to do the 4th launch. If that 4th launch had failed, we would have been dead. So multiple failures along the way. I tried very hard to get the right expertise in for SpaceX. I tried hard to find a great chief engineer for the rocket. The good chief engineers wouldn't join, and the bad ones, well, there was no point in hiring them. So I ended up being chief engineer of the rocket. So if I could have found somebody better, then we would have maybe had less than 3 failures.
Hi and welcome back. In this video, we're going to look at installing packages in Python using the console. At this point, if you don't have Python 3.5 or higher installed, I recommend that you go and download and install that now. I'd recommend you install the latest version of Python that is stable. At the current time of recording, that's 3.6, but when you're watching this, maybe 3.7 or later. I recommend you install that just because, you want to stay ahead of the curve, you want to use the latest technologies, and taking a course is a great opportunity to adopt a new technology. So I recommend you install the latest version, and also that's because later versions of Python come with, when you install them, a program called pip. That's pip, like that. Pip is used to install Python packages. Okay, so if we do pip install requests, for example, what this is going to do is it's going to go over to various websites and it's going to look and see if it can find a Python package or library called requests. And if it can find it, it's going to install it. So I press enter. And as you can see, I get requirement already satisfied. That's because I've already installed requests, but the fact that it's telling me this means that requests exists. So that's good. This is what PyCharm is doing in the background when you tell it to install a library. All it's doing is it's doing pip install and then the library that you ask it to install. Okay, as you can see, the requests library is already installed in this folder here. USR local lib python 2.7/site packages. This tells us that the requests package we try to install right now, we try to install it for Python 2.7. We did not try to install it for Python 3.7. If you want to install for Python 3.7, you'll have to do pip 3.7 install requests. If you only have one version of Python installed, i.e. you're using Windows or maybe Linux and you don't have multiple versions of Python installed, you only have to do pip install requests, okay? This is what to do if you only have one version of Python installed. But if you have many, you can do pip 3 in order to choose the latest version of Python 3, or pip 3.7 in order to choose Python 3.7, and that's where you're installing. So again, pip 3.7 install requests, And it'll tell me now the requirement's already satisfied, but notice how now the location of where it is already satisfied is different. That's because I've installed Python 3.7 in a different way than Python 2.7. Python 2.7 comes with my computer. Python 3.7 I've installed using the official installer. So this is how you'd install packages using pip. And a package we're going to want to install now is one that you may already have, but nonetheless it's a good idea to make sure you've got it. It is called virtualenv. Okay, as you can see, it tells me that I've already satisfied this, but if you don't have virtualenv installed already, I recommend that you do install it. When you use this virtualenv package, what you can do is you can duplicate an existing Python installation. So let's say you've got Python 3.7 installed. You can use virtualenv to make a copy of that, but without any of the libraries that you've already installed. As you can see, I've got requests already installed in Python 3.7. If I create a virtual environment using Python 3.7, it won't have requests installed. So let's do just now. The way to do that is by typing virtualenv, then the name of the virtual environment, it's normally venv, -- python equal Python 3.7. Again, instead of Python 3.7, you can type Python if you only have one version of Python installed. By doing this, I'm saying run the virtualenv program, which again must be in my path. And these here are two arguments that I'm passing to that program. And programs in the terminal can accept arguments. venv is the first argument, and -- python equal Python 3.7 is the second argument. The first argument is the name of the venv, of the virtual environment, which is in this case going to be venv. The second argument tells the venv what program to run, that's Python 3.7, when we are creating the virtual environment. So it's going to use Python 3.7 for this virtual environment. So let's do just that. Notice how a few things happen. It says it's using the interpreter Python 3.7, and then it installs a couple of things like setup tools, pip, and wheel. Those are a few libraries that are very useful for installing packages. And then it's done. Now, inside your venv, so what we're going to do is we're going to open the current folder in my Explorer so that you can see exactly what we've got here. Let me just bring it up. This is the VM folder that we've just created. We've got a bunch of things. We've got bin, and then here we've got, Python, Python 3.7, Python 3. These are all Python programs that we can run. You've got pip that you can run as well. You've got a program called activate. If you're using Windows, this may look slightly different. You may have a scripts folder in here. That's totally fine. Now, when you type which Python 3.7, you can see that the Python 3.7 that we're going to run is still this one inside library frameworks. If we do source.venv bin activate, and then we type which Python 3.7 again, now you can see that we are using our venv folder. Inside it we've got bin, and inside it we've got Python 3.7. So what we're doing now is we're using a completely different version of Python. Well, it's actually the same version, but it's a completely different installation of Python. Before we were using this one in our library. Now we're using the one in our venv. By the way, if you're using Windows, it won't be source.venv bin activate. If you're using Windows, it'll be /venv scripts activate.bat. So if you're using Windows, you want to run this line here instead of this one, okay? But I'm not using Windows, so I don't need to do that. You can also see that you've got /venv inside brackets at the start. That tells you that you are currently using this virtual environment. Okay. If you echo the path, you can see that now you've got something at the start of the path. /users/svtr/venv/bin. Before, we had this at the first folder. Now we've got this one. So any programs we try to run are first going to be looked at inside this venv folder. For example, Python 3.7. This is really powerful because now, if we type Python 3.7, we're using the Python 3.7 in our virtual environment. If we then type import requests, you can see that it cannot be found. It's not installed. So if you want to install requests, now you can do pip install requests. And that's going to install the requests library inside your virtual environment. If you were then to go and create another virtual environment and call it something else, it would not have the requests library. So these libraries, when you're using a virtual environment, are only installed within the virtual environment. This is really great because it lets you have different virtual environments, each with different versions of the same library, potentially. Let's say you start a project today and you install requests, version 2.18.4. And you develop this project over a period of a few months or a couple of years, and you never update the requests library. But then you start a new project, and you want to use the latest version of requests because maybe they fixed a bug or something. You can do that. You can create a new virtual environment and install the latest version, and the old project that's using this version will not be affected. Imagine they've also changed some of the functionality so that your old project would no longer work. Now you don't have that problem because each project can have its own independent versions. And by the way, this takes up a few megabytes of your hard drive, and it's essentially free. It doesn't cost you anything to have multiple virtual environments. I have many Python projects in my computer. Each one has its own virtual environment to keep it separate from every other project. So moving forwards, whenever you start a new project in Python, create a virtual environment for it and make sure to use that whenever you're running your applications. Over the rest of the course, we're going to be creating virtual environments for our projects, just to give you some examples of how this works. Now that you're in your VM though, if you did have some Python files that you want to run, for example, like an app.py or something, all you have to do is type Python app.py, and that's going to run the Python program in your path, which is Python 3.7, because that's what's in your venv, and then it's going to run the file app.py, which is presumably the file that starts up your program. So this is how you would run a specific file with Python from within your console, and you can do that within a virtual environment. So that's going to, again, give separation between your projects, and it's going to make them a bit more independent. That's it for this video though. It's getting a bit longer now, so let's continue in the next one.
If you just keep trying to change your environment, hoping that your life's going to improve, you're going to feel dissatisfied at the next place. And I feel we're just conditioned to say, okay, you don't like your job, quit your job. You don't like your relationship, quit your relationship. And I think we just keep saying that it's this external shell that we're in, when it's actually this shell and what's happening inside of it that's defining all of these perspectives.
Hi and welcome back. In this video, I wanted to show you a couple of commands that you can run in order to navigate your computer using the terminal. These can be quite handy. The commands I'm going to show you are only going to work on Mac OS X and on Linux, but I'm going to give you the Windows equivalents as well. So when you are on Mac OS X or Linux, you can type pwd, and that tells you the folder you're currently in. So in my case, I am in /users/JSLVTR. On Windows, this will be dir for directory. If you want to move to a different folder, you can do cd for change directory, and then you can type whatever folder you want. So for example, if you wanted to go to your desktop, you could type desktop. Notice how now I am in my desktop here, and if I type pwd, I am now moved to my desktop. On Windows, this would be chdir for change directory. Now, of course, the desktop folder that we've just moved into is inside users/JSLVTR. Otherwise, it would tell us folder not found. For example, I'm now in my desktop. If I try to do cd into an ASDF folder, it says no such file or directory. So you have to make sure that the folder you want to move into is inside the folder you're currently in. However, you can also choose to move to a particular folder even if it's not inside where you currently are. In order to do that, you have to tell your computer the absolute path to that folder, starting at the very root. In Windows, you would do change directory of C, going to C/users/something, or C/data/whatever. And in OS X and in Linux, you do CD /, which means the root of your computer. And then you could do something like library, Python, and so forth. Then you can change directly into this folder. This is where I am now. As a small aside, if you want to go back to the previous folder, you can just type cd-. And this, I don't think, works on Windows. It just works on Mac OS X and on Linux. If you want to look at what currently is in one of your folders, all you have to do is type the ls command. On Windows, this will also be the dir command. Okay, so let's go over to one of the scraping books project, for example, that we created earlier on in the course. Then we can type the ls command and we can see that we've got a few things here. Some of these things are newer. You may not have seen them yet because they are part of the asynchronous development section. The project here has been modified slightly, but don't worry, all is good. What we've got in the course has not changed. This is just some new stuff that I've added. And you can see that we've got here app.py, we've got this async request.py, menu.py, and so forth. There's even some folders you may not have seen before, like this PyCache folder. That is fine, you don't have to worry about the PyCache, it's just a Python thing. Now, if we wanted to run this project here, we could do that in my case, I'm going to type Python 3.6 because I remember when we started this project, I was using Python 3.6. Python 3.6 menu.py, and then our application starts running, and we've got some extra logging that we added later on. I know that you've maybe not seen this, but nonetheless, our program starts working, and then you'll see the menu appear, and you can interact with it. This is just a program running as if it was running inside PyCharm. Now it's running inside this text console that you've got here. However, we had to run Python 3.6 in order to run this project. If we wanted to create a virtual environment for this project so it was separate from the system installation of Python 3.6, we can do that. All we have to do is say virtualenv venv --python equal Python. I'm going to use Python 3.7 for this virtual environment. This is going to create a brand new virtual environment. And now when we type ls, we can see that there is a virtual environment folder that wasn't here before. This is the Python installation that we have copied into here. And it doesn't have any of the libraries that it had before. So if we activate, by doing this, remember to do, venv scripts activate.bat on Windows. Don't do that on Mac, but do that on Windows. So if we activate and we try to run our menu, now it says, no module named whatever it is that we needed. And again, this has changed slightly since the last time that we saw this project, but nonetheless, Beautiful Soup would also be another one that wouldn't be found. If so, all you have to do is pip install and install everything that it asks you as it asks you it. We can then repeat. And by the way, I'm cycling through old commands by pressing the up arrow in my console. Now it says requests couldn't be found, so we can install requests. We can also install Beautiful Soup 4. And I think that's it. There you have it. Now the program is running. We've installed all the libraries in our virtual environment that we needed, and our program is now working. So that's all we need in order to make it work. Now, if you type pip freeze, this is going to give you the libraries that are installed currently in your version of Python that you're using. The version of Python we're using is the one in our virtual environment. So this gives us the libraries installed in our virtual environment. Notice how they are in the format of iohttp == 3.0.5. So we've got version 3.0.5 of this library. We've got version 2.18.4 of requests, and so forth. And it's fairly frequent when using virtual environments to actually save these into a file. And just so you don't forget that these are the versions you've got installed in this virtual environment. When you give this program to someone else, they can then go and install the exact same versions. So we can create a new file and put this content in it. You can do that in PyCharm, or you can do that in any other editor. Or if you want, if you're using Mac OS X or Linux, you can do pip freeze into requirements.txt. All this does is it says all the output of pip freeze, instead of printing it out, dump it into this new file called requirements.txt. Okay. Now if you were to open requirements.txt, you'd see that it contains all of this stuff. Okay. In Mac OS X and Linux, you can do the cat command in order to see the contents of a file. So as you can see, when I do cat requirements.txt, you can see the contents of the file here. Now, why is this useful? If now I'm going to go and do pip install, if you share this with someone else, they're going to have to go and do pip install iohttp. I mean, do they do this? Do they do == 305 in order to install the specific version? Yeah. This is what you do in order to install version 3.0.5 of this library. But if you share with them this requirements.txt file, they can actually do -r requirements.txt. So pip install -r requirements.txt, and then they're going to go through and install all of these libraries, these specific versions of them. So as you can see, this can be really good to share everything you need for a project with someone else. For example, if you're working with someone else or you want to participate in some sort of team, you're probably going to want a requirements.txt file so that you can share it with one another and make sure that you're all using the same versions of libraries. If one person in a team is using a specific version and someone else is using a different version, you may actually encounter some inconsistencies and some things that may work differently. So make sure to not do that. And by having a requirements.txt file is a great first step towards making sure that you're all on the same page. So that is how you would install everything from a requirements.txt file, and as you can see, it's all pretty straightforward. Over the next few videos, we're going to look at something even more important when working with these projects. And also, this new thing that we're going to look at in the next few videos is actually the recommended way of managing projects and dependencies in Python as of Python 3.7. So stay with me, and I'll see you on the next video.
Through my movies and my characters, I've tried to celebrate flawed people because at the end of the day, it's the imperfections that make a character compelling. So what I'm trying to say is, being yourself is truly the greatest impact that you can make.
Hi and welcome back. In this video, we're going to not use virtual environments, but use something else that builds on top of them in order to make dealing with these projects and dependencies a little bit easier. Enter Pipenv. Pipenv, spelled like this, is a new library that has now become the standard for managing projects and dependencies in Python. virtualenv was the standard up until maybe a year ago or so. But now Pipenv has taken over just because it's slightly better and slightly simpler to work with. The first thing we have to do is delete the virtual environment we've already created if we are going to use Pipenv instead. In order to delete a virtual environment, make sure to stop using it by typing deactivate. If you type deactivate once you've activated, you will come out of the virtual environment. I'll show you exactly what I mean. I'm going to do activate vm bin activate, source vm bin activate, and then deactivate will just bring you out of it. As you can see, the VM inside the brackets disappears, and we're back at our normal Python. You can double check by typing which Python, and you'll see that you're no longer using the virtual environment's Python here, you're using the system Python. Okay, then we're going to remove the virtualenv folder that we've created. So we're going to do rm-rf venv. I'm not actually sure of the Windows command, so I'll make sure that it appears here on the lecture. But what this does is it deletes the folder that we've created called venv. So just type that. When you type ls again, you'll see that the venv folder is gone. It no longer exists because we have now removed it. This remove command is what it does. It removes things. Then the next thing you must do is make sure you use pip, and make sure you use pip 3.6 or 3.7 to install pipenv. I've already got it installed, but if you don't have it installed and you get some sort of error, you may have to do pip 3.7 install --upgrade pip. That just allows pip to upgrade itself to the latest version, and then you'll be able to do pip 3.7 install pipenv again. Once you've got pipenv installed, all you have to do is type pipenv, and then you get all the commands and usage examples that you may need. The most important one is the install. Okay. If you have a requirements.txt file already created, then typing pipenv install is going to use that requirements.txt, and it's going to install all the packages in that requirements.txt into the new environment. Notice how the first thing this does is it creates a virtual env for the project, and then sort of it goes through and it installs a bunch of things, and it creates a pip file, and it creates a pip file.lock. We're going to explain what these are in just a moment. And at the end, you have your setup complete. If you type ls, you can see that there's a couple more things now. You've got a pip file, and you've got pip file.lock. Let's open up the pip file to see what's in it. So I'm going to do cat pip file to see the contents of the pip file. So these here are the contents of the pip file. You've got a source URL, that's where you're downloading your packages from. Verify SSL, whether you want to make sure that the certificates you're using for SSL are correct, the name of where you're downloading from, that's the source. And then the important part here are the packages you've got installed, and notice how they're coming direct from my requirements.txt file. So this is all good. The pip file.lock is much longer. As you can see, it is quite long and it has a lot of stuff in it. I typed the command up here, so all of this is my pip file.lock. And what this is a bunch of hashes. And these hashes are the version and sort of some of the contents of the libraries that we've installed encoded into this. So essentially, the entire library has been converted into this number. If the library changes, the number will change. So what is the point of having these numbers? Well, this number is a representation of the library. Again, if the library changes, the number changes. So let's say somebody hacks into the place you're installing your libraries from, and then change the library without changing the version number. You could potentially install the hacked library by accident, because you wouldn't have a way to tell. But if the entire library is converted into a number, and this number is generated from the library, so if the library changes, the number is going to change as well, you're not going to be able to install a wrong library by accident, because now you're checking against this hash. Really, the way this works is quite complex, but that is the general idea behind it, so that if the library changes with or without you knowing, you're not going to accidentally install a wrong version or a hacked version, essentially. So that is the purpose of the pip file.lock. Now we can remove our requirements.txt file because all of its contents are inside our pip file. Instead of sharing a requirements.txt file with people, you can now share a pip file and the pipfile.lock with people. If they have both of those and they type pipenv install, the pipenv is going to get the contents of the pip file and of the pipfile.lock and make sure to install everything that you need. Now, because we've got a pipfile.lock, we don't actually need a couple of things inside our pip file, which get added there by virtue of us having a requirements.txt file. So if you remember, the requirements.txt file had the version numbers of everything we needed. But the pipfile.lock also has the version numbers of everything, and it has added security, which is this number that's generated from the library. So now we have the version numbers and the security on the pipfile.lock and on the pip file. We don't need it in two places, so we can actually tell the pip file to install any version of the library. Then pipenv is going to make sure to install the one in the pipfile.lock. So let's go ahead and modify our pip file. And I'm going to do this by using the vi command. So I'm going to type vi pipfile. This is not available on Windows. You may want to just open it with a notepad or with PyCharm. But this is going to let me modify this folder here. And all I'm going to do is I'm going to remove the version numbers and replace them by asterisks. Make sure to not forget the quotation marks around things. That can be quite a dangerous thing to forget. Now that we've got all of these using any version, as opposed to a specific version, we can save that. That is what I've done there. I'm not going to go into how VI works in this course. It's a bit more, just different content. It's not really more advanced. It's just a bit different. Not really the place for that. But now that you've modified the file, what the pip file is saying is, these are the libraries I need. What the pipfile.lock is saying is, these are the versions I need. So now you have these two files here. The pipfile.lock has a lot of information on exactly what you want to download. And if it doesn't match exactly, you're going to get an error. And it's going to say, hey, we're trying to install this, but it doesn't match what we thought it should be, this number. So we're not going to do it. And that's for security. And the pip file is telling you, these are the libraries you need. So this now is a better setup, a more secure setup than just using requirements.txt. And that is why pipenv has now become the new standard in Python for dependency management. Once you've got your pip file and your pipfile.lock created, and you've done your pipenv install, what's actually happened in the background, and we saw that earlier up here, is that there was a virtual environment created. Let's have a look at what this virtual environment looks like in the very next video. I'll see you there.
We shared this stage 15 years, me and him. I don't know if it's ever happened in football. The same two guys in the same stage all the time. So it's not easy, as you know. And of course, we have a good relationship. We not had a dinner together yet, but I hope in the future, I hope to be here next year and in 2 years, in 3 years. So the people who don't like me, they're gonna see me here.
Hi and welcome back. In this video, we're going to use a virtualenv with the pipenv. In the last video, we saw that when we did pipenv install, this created a virtual environment for our project. But there is no virtual environment folder inside our project. There's only a pip file and a pipfile.lock. Indeed, the virtualenv location is a different folder entirely. It's this /users /jsavtr.local/share/virtualenvs/scraping books -random numbers and letters. Sorry about that. So pipenv has actually created the virtual environment in an entirely different place, which is a unique folder just for this project. Whenever you use pipenv, you can do run Python. And this is going to run the Python interpreter in that virtual environment. So when you precede anything by pipenv run, that's going to use the virtual environment that was created for you, not inside this folder but in somewhere else, as where your programs are running. So now you no longer need to activate and deactivate. All you have to do is ask pipenv to run whatever it is you want to run. So as you can see, when we typed pipenv run Python, that went straight to Python 3.7, which is what we used in our virtual environment that was created by pipenv. If we exit here by typing Control D, and we type pipenv run python menu.py, you can see that it all works. All the packages are installed in the virtual environment, but the virtual environment is not inside this folder, it's somewhere else. And that's everything working there. So pipenv actually helps you clean up your development environment. You can no longer have the VM, or you will no longer have the VM inside this folder here, because pipenv says this folder is for your code and for your project. It's not for, your Python installation. That doesn't make any sense. So you keep your pip file and your pip file lock in your project. And if you share this project with someone else, they will also have a pip file and a pipfile.lock. They can also type pipenv install. They will get their own virtual environment created somewhere else, unique to them in their own computers, and not inside the project folder. So whenever you create a new project, now instead of creating a virtual environment, just use pipenv, and it will be easy to manage all your projects. In addition, you don't have to remember to activate and deactivate. Pipenv will manage your virtual environments for you. Whenever you type pipenv run, it will know how to use the correct virtual environment. However, there's a caveat for that. If you move your project, we've got this scraping books folder. If I move that folder somewhere else, pipenv will no longer be able to find the correct virtual environment, so you'll have to recreate it. Okay, that's the only problem with pipenv. If you move the project, you will have to recreate the virtual environment. And that is because of the way that it creates the virtual environment. It creates it depending on where your project is, and if you move it, it sort of loses that knowledge of where it was. That's it for this video. I just wanted to show you how to use pipenv. And there's a bit more to pipenv that you can use. If you type pipenv, you'll get a few other commands like, how to uninstall libraries and things like that. There's some investigation you can do if you want to go into more advanced pipenv stuff, but don't worry too much about it. What you need to know is how to install it, how to run it, in order to simplify your project management. Again, that's it for this video, and I'll see you on the next one.